Is the mic okay as it is?
It is, yeah, we can hear you.
Okay. This is always a little bit difficult depending upon the Zoom tool or whatever it is, it might depend. So, yes, it's for beginners what I'm talking about, but I must also say that, it is something, well, autonomous real-time testing is something for people who actually love and accept to look at various different disciplines and mix things together, which you don't easily mix, for instance, as we do, mathematical logic and marketing, user needs. So I hope you'll enjoy it. So art naturally is something beautiful. I'll show you first of all where I'm coming from. Actually, yes, I'm not a beginner. I made my doctor thesis many years ago, namely 40 years. And it was about mathematics. At the time, computers looked like a DEC 10 or a PDP 11, something which you nowadays would think it's ripe for the museum. Actually, it is ripe for the museum. And we were very proud when we had the memory capacity of our computer, interactive computer, augmented from half a megabyte to 1 megabyte. That was those old times. But in between, I made a lot of other things, such as Six Sigma for software, quality function deployment, CMMI, Net Promoter. Net Promoter is probably something which you, well, most of it you probably haven't even heard of. But Net Promoter is all this kind of asking people whether they would dare to recommend something or not. So, and that's where I actually live. You see, down under these hills, it's a wonderful place. But at the moment, it wouldn't look like this. It is just foggy and it's cold and it's December. My collaborator Marcel actually is mastermind in most of the things which I will mention. Such as virtualization, cloud, container, serverless, machine learning, Docker and Kubernetes, Internet of Things, and so on. So his contribution is very substantial to this presentation. So let me just start with the goals. I hope that I can explain you why software testing is an autonomous activity which goes parallel to DevOps, and not something which is shift left and shift right, or in between, like dev test ops or dev. I don't know. No, it's an autonomous activity, and it is as important as developing a product. So it is something which goes in parallel, and it is model-based. Software testing is not just testing code. No, the code is certainly important, but today we don't have always code. We have services, and the services come from the cloud, and we have no access to code. So all we can do when we do testing is actually must be model-based. Otherwise, we're probably testing the wrong things. Naturally, it's not wrong to test code. Every code which exists is something that must have undergone some tests that actually delivers something well known, but what it actually delivers is possibly also exploratory. Test cases can be automatically generated and selected for relevance using combinatory logic and user values. So here you see the combinatory logic, which is from my mathematical background as a logician, mathematical logic, and users values is from the marketing side of my background, which I have shown you. Net Promoter Score, for instance, is something that measures users' values or tries to measure users' values. And we are using users' values in order to automate tests. So test cases can be executed automatically. This is something which required the help of my friend Marcel, actually, using Kubernetes custom resources and digital twins. And finally, the goal, continuous software testing is the most important activity in the DevOps to create confidence in cyber-physical products. So what are cyber-physical products? Well, let me start with autonomous testing. Well, there was upon a time when steam power was the most advanced technology. With mechanical production, railways, and so on. Then came electricity. We had testers here trying to find out whether there is actually current or not. Oh, yes, there is. Then came the silicon microprocessors, information technology, and fast Fourier transform, electronics in the fast Fourier transform, by the way. Who knows why we can see all these images in the internet? Oh, yeah, fast Fourier transform was invented in 1977. Before that, there was a strict limitation of computers to numerical processing. So, and nowadays we are gone in the fourth industrial revolution, namely the revolution where we have cyber-physical systems. And I will actually talking much about testing of cyber-physical systems. And you will see that testing cyber-physical systems is quite a bit different from testing silicon microprocessors. And something which I really think makes me a little bit also difficult to understand, difficult to communicate, because the move between the third and the fourth generation of industrial revolution is not yet understood. This is something that currently goes. Well, what's the problem with cyber-physical systems? Would you ever dare to use an autonomous vehicle? Sit in such a car and let you drive through the streets of Kiev or New York or Napoli? Well, you have software updates every 10 days, you have connected with smartphones, you have cloud services, and the car learns new behavior. It's quite a difference to old-fashioned software that behaves according to the code that programs it. Or if, say, in the area of COVID, you can ask yourself whether you trust a medical instrument. Also, software updates every 10 days, connects with healthcare systems of various antiquity, and uses artificial intelligence to analyze what it sees. How would you test such things? Well, let me first show you a little bit the thought about continuous integration, continuous deployment, the famous DevOps. That was DevOps as it originally looked like. You create something, build, test, release, deploy, operate, monitor. Today we have an understanding that actually testing should be shifted left, as some people take it and say, well, you should start actually with the test from the very beginning in the creation phase, and well, and then you deploy and testing finishes. No. Autonomous real-time testing means you never stop testing. The test continues while the cyber-physical systems remains in operation. It's even more important that you continue like that, because if the cyber-physical system learns something, it can also unlearn. Like humans, we also unlearn. Try, for instance, to use a phone or fax service nowadays with young people. They look at it, they have unlearned how to do it. And our cyber-physical systems can unlearn as well. So you should be very careful about including the operational part of DevOps into testing. But how can this be done? Just to say short, autonomous real-time testing, it's ART, tests run anytime, anywhere, in a limited time slot and individually. Say, I'm thinking of a car parked in a garage or a parking lot, and while it's being updated with new software releases, they run certain tests autonomously on the car, and the tests are even adapted individually to what the car usually experiences. So this is what I understand as autonomous testing, new approach. But this is not so simple. You cannot simply record your automated tests and play them on the car, because the car, it has devices, it has cameras, it has lidars, it has a motor, an engine, steering, a lot of functionalities which actually should be tested somehow. So first of all, what should we do with all the functionality? The problem with test automation is that we can probably really automate the test only functionality. Naturally, you can do an UI test and then see whether the new version of the program simply produces the same UI as before, and this you can do automatically. But probably at the end, the UI test is more something that is tested by humans and not by robots. And we are talking here about autonomous testing by robots, by software testing itself. Or we will see artificial intelligence that tests artificial intelligence. The problem with test automation is you must be able to measure. If you can't measure functionality, you don't do automation. If you can't measure test size, how should you be able to make sure that you're actually going to test functionality? Which functionality you're going to test? So this is probably my very first thing that I want to urge you. Really, this is really important. If you do not use functional size measurement, you can't do testing right. And I know that very few people actually employ functional size measurement because they don't know it, or they don't know for what it's good for. In fact, functional size measurement is, in the version that I'm using for testing, is looking after the data movements, and it counts the number of data movements as a size, and for this it uses a simplifying UML model. So testers and developers can walk the data movements when planning or executing tests. You see it already here. What I wrote here, functional process, some device, other devices, other app, it is not code testing that we do here. We really test what the functionality provides. We can test on any level. We do not need to go always on the deepest level if we, for instance, want to test whether a car behaves correctly when he encounters a child playing with a football, for instance. But here we use a standard from ISO the 19761, COSMIC, which allows to model software by its functionality and counting it as size. The count itself is less important than to understand how you describe functionality in a standardized, easy way, which can be tested. So if you can do that, then you can say functional size compared to test size, and you can speak about test coverage in a well-defined manner. Namely, test coverage is very simple: which test stories cover which user stories, and the way that they combine are the functional size data movements. Actually, there is a problem with test size. So if you have old-fashioned third-generation software, commercial, administrative, you probably have a function size of, well, 5,000. That's typically for administration, 5,000 function points. With a test intensity of 10 gives you a total test size of 50,000 function points. That is, you have to write tests that cover 50,000 data movements, and well, that is in average 10 times every data movement. Yes, well, that's a work which is impressive, if done, very interesting. However, still can be made by humans. So now we use a safety critical software, a medical instrument or ADAS or something like this. Functional size increases quite a bit. Test intensity should increase as well, because it's the software can start to be to harm people, and total test size is then significantly higher. And if you look after complex software-intensive systems like the plane or the train or autonomous car or something like this, yes, this is that they will actually coming out with so many tests. It is not possible to write test cases by humans that cover such a system. We need automation, not only for executing tests, no, for generating test cases. Otherwise, we do it like we actually do it. I mean, we just try to fly with the plane, and then we are wondering why it crashes, and the trains take years for commissioning. Autonomous car, as you can see, we wait for them already 10 years, and well, we're still waiting. Here you see what the reason is why we use this model-based testing. I wrote a model for autonomous driving of a vehicle with only 37 data movements. We don't have to test all the code. We know that there is a lot of functionality in this coding, but at the moment when we want to know whether it's able to do autonomous driving, probably we can start with only these 37 data movements and assess the layer, how it works. For instance, here we have a functionality. Well, that is only a very, very small point out of the total that we currently have. So that makes autonomous testing feasible. But how can we actually go ahead and making sure that we really test something relevant? For this, I want to show you a little bit more about combinatory logic. Combinatory logic has a wonderful model, and the model is very near to test data, test cases. it is important here to note that actually the model is well, it's a formal model. You have test data which formally yield a test result. In between, in behind of it, you have the data movement map who actually can execute such a model. These, I'll call that arrow terms, but you don't need to remember that. This constitute a combinatory algebra, which actually has wonderful theoretical properties. These theoretical properties are uttermost important if we want to use them for specific tasks, because we can use them to enlarge the test coverage. Yes, test data refer to the specific data groups. Actually, this is referring to the cosmic way of describing functionality. We have these data groups that are moved around for in our software models. And important is also the notion of test stories, because the test stories actually are the collections of test cases that have a coherent scope, a business meaning. And we will see test stories is actually what we need to develop as we develop user stories in parallel with when we do develop, say, in an agile manner, a product, a new product, a cyber physical product. So these test stories are important. So why is this combinatory logic so useful for us? Because combinatory logic actually allows to combine test cases. It looks very simple. You combine a test case with another one if you have enough tests available that produce the results that are actually needed in the second test case, redefined in the right-hand test cases. This looks like something logical, but for programmers, it simply means actually you can build up a full test by combining even, say, the initial unit tests. And then you have exactly what Nikolai have spoken about, a full test stack, which actually has no demilitarized zoning between and no vacuum between developers and test engineers, because actually the test engineers use the stuff prepared by the developers in their unit tests to combine. You can combine as long as you want. You have an explosion. You have infinite number of possible tests by variations of test data, test results on various levels. So what should that help? So you have here your test cases. This is the fountain, a photo from the fountain of the Opera House of Kiev, I think. You can now generate as many test cases as you want with coherent test scenarios, variations of test data, by combining test cases from various devices, for instance, or say unit tests from various components in a system of systems, like in an autonomous car. You can combine test cases from the weather forecast, from the sensors looking at the street composure, or from the traffic service, navigation service, which tells you about traffic jams and where to go, recommendations where to go, for instance. So you can combine every test with any other test by combinatory algebra, and you have a traceability. But what you should do with those many tests? The water is flowing, and what should that help? For this, you need now something which I explained in the beginning is actually originating from marketing, from user behavior, from the values of the user. There are many ways of explaining it, but basically it means we need something that describes what's important for the user. For instance, a user of a car, he wants to arrive in a predictable time frame. That is, he doesn't want to have any accident, he doesn't want to have any incident, he doesn't want to get stuck in a traffic jam. He wants to arrive when he actually can arrive under normal or under the current situation. It naturally depends whether it's snowing or whether it's heavy traffic. It will not be always the same time, but it must be predictable. That's, for instance, a value that a car user has. But there's many other values as well, naturally. He also wants to use a car which looks good and which is comfortable and make the neighbors envy him a little bit. Well, effective, he has his goal profile for user values, which includes needs for privacy, security, emotional, business needs, and the car, the system which is providing that values, should be capable of providing exactly those values. So the user stories actually do provide those product characteristics such that these values are fulfilled. For this, we have Six Sigma transfer functions. Transfer functions are, in our case, always linear, and you can do that by linear algebra. Now comes mathematics into play. That is, you have means of calculate effectivity for user stories in terms of those user values. Naturally, you first must know the user values. It's not enough just to believe in some user values, but if you know them, you can really adapt the user stories that you are going to implement to these user values. And this makes your product attractive. This always makes your product attractive, but not always this has been used so consciously. And the same technique is used for looking after the test coverage. But now you look after the test stories, those collection of test cases that test your user stories. This should also cover your user stories. The user stories should be covered by the tests you are providing. So this means you have a means to even automatically select the right test cases from the fountain of test cases that we have seen in our beautiful fountain. And this is, by the way, this is called quality function deployment. Quality function deployment has been invented in Japan 40 years ago or even 50 years ago and adopted today for many things, including doing product development in a modern way and agile. This too is an ISO standard. It's the 16355 ISO standard. And now, naturally, the point is I'll speaking about two ISO standards. You probably have never heard about them, bringing them together. And I must admit that possibly not many people actually see how those two ISO standards cooperate. But together, their power is enormous and impressive. So it is worth looking after it. So I'll show you here, for instance, 6 user stories, which still belong to, in some way, to this autonomous vehicle program with the 37 function points that I've shown you before. And these user stories cover a number of data movements. So every of these user stories actually uses a certain number of data movements, and because a data movement can serve more than just one user stories, you have more than the 37 total data movements. You can have multiple usages of same data movements for different user stories. This is normal to be expected. So if you now compare this profile which you got by these data movements, then you get something like a priority. Priorities are well known by the development teams that use Agile. Usually they have to select the user stories for their priorities. How do now the priorities relate to tests? Well, you very simply use the total number of data movements in the test cases that relate to the user stories. So this is actually why measuring test size, measuring functional size is so important, because it allows you to speak something really interesting about test coverage. It means that you actually test what the customer expects, what has value for him. You do it via the two transfer functions that I've shown you before, but actually you have something that that can even be used for automation. You can use it for automation. Actually, the nice little girl here is not yet doing it for automation. It simply falls in love with doing test stories right, in the sense of with respect to the value for the user. There is a little bit of mathematics, namely, we have seen here the convergence gap. The convergence gap is nothing else than actually how well these tests actually fulfill the user needs. This is can be calculated mathematically by using a little bit matrix calculation, and help you to determine whether your test stories actually match user needs. Nothing so difficult, but very, very, very helpful if you're really interested in testing the right things. The convergence gap is then just showing whether those newly generated test cases are relevant for the user, and that means you can use the convergence gap for determining which of those many test cases that you can generate are actually useful. So let me just summarize that a very little bit. You have, first of all, you have the ability to combine tests as freely as you want. You second have something that helps you selecting those that are important. What's that? We call that today artificial intelligence. Artificial intelligence is wonderful, but you can be intelligent without being artificial. You can do that manually, and even manually, it helps you already a lot when you actually want to test anything that you want to have as a product for people. So this is actually the most important thing that I want to relate. Now, a little bit of goodie for the technical people who probably I'm a little bit overwhelming with kernels and values. To implement that, it is not too difficult, actually. We have seen by Nikolai how you do it, and my understanding of ZappleTech is absolutely capable of doing such things. The important point naturally is you need to have test steps for all your appliances that you are actually going under test. You can't test the hardware in the loop autonomously in the garage. You must have digital twins. And how do you do that? Well, Kubernetes. Use Kubernetes custom resources such that you can actually add the test cases to your product. This means you simply have in the same environment, you have also your testing environment, which or your test cases, which you can run anywhere, anytime, unattended. Real-time is also needed because you have a limited amount of time at disposition, and the car, for instance, is not a supercomputer with unlimited resources, but the car actually connects to the cloud, and you can use the cloud resources to allocate the necessary power for doing all the necessary or all the calculations, but still based on the software that's actually running on the car after all these updates and all the connections with the smartphones. So, solution idea, you track sensors and cameras, track responses of actuators, build individual history per system. That works well for autonomous car, Internet of Things, airplanes, train sets, whatever you have. And you get every component. You have a digital twin that's actually where it is actually needed, and then you play a virtual orchestra. Sounds simple. In fact, yes, from the approach, it's simple. From the realization, it's naturally impressive. But you shouldn't forget, I mean, if you're, for instance, trying to build a train set, then it can easily be that you need nowadays 7 years to commission that train. These 7 years are not for free. So you can actually spend a little bit of money if you really want, and it would still help producers of those cyber-physical products to save money. Technically speaking, you, as I said already, use custom resources in Kubernetes. You use sidecar container in Istio to do all the necessary metrics, which actually, because you want to measure and to measure what you really use. Therefore, best is you measure in the moment when you actually execute those tests. Definitely don't want to go into much detail with these custom resources. I'm sure that, I think we had a lot of people here who can do it much better than I can. So let me come to the end of my presentation. Create confidence. The compliance is something that is very valuable for customers. It is important. It helps them a lot. You need to charge the customer for such value if you want to provide him. And this is why we use those metrics. We have times that are changing. Compliance has become paramount for medical instruments. We have now in the EU a new directive on it. It is not yet well known how it actually should ever help autonomous vehicles to hit the road. For artificial intelligence, we have little bit more information what we should actually do. It is model-based, but we are not yet sure what compliance should be when artificial intelligence actually learns new behavior. We have the Internet of Things, which is actually, say, the first instance where you have to start with when you are doing autonomous real-time testing, but also of the future cyber-physical systems. And we are only at the beginning of the fourth industrial revolution. All sorts of future cyber-physical systems will have that compliance issue. So we address that by testing becomes integral part of product development. As is, test stories must become equally important as user stories. Whenever you start writing down user stories, you need the test stories that relate to these user stories. You need to keep the test coverage matrix growing, and you can, from the beginning, you can actually start filling the matrix by the test cases which you are actually using for measuring those user stories. And that means, yes, Agile was yesterday. DevOps is here since 10 years, but the fourth industrial revolution will actually need to adapt DevOps and Agile in order to include compliance, and autonomous real-time testing is probably the important step towards testing compliance autonomously in our cyber-physical products. So functional testing is from the beginning. Well, I've said that already. We start from the beginning with the test coverage matrix. We need that to do in all phases of the DevOps cycle. In that sense, ART is not a tool, but it is really an approach that combines automated testing with combinatory logic and user-centric product development. Well, and I say today we have all those means and tools at disposition that we need to implement ART and to do it right from the beginning. The only thing is we have to start with. I wrote a book about autonomous real-time testing because I know this is something that is not easily coverable in 40 minutes. Also a book about these transfer functions, which are so instrumental for doing ART right. And this was my talk. Oops. Thank you very much. And I'm ready for...
Thank you so much. That was fantastic.
Stop sharing, yes.
So we do have a question from Mark that came into the chat. And he said the functional explanation might also be found in modern techniques for chaos testing in production. So I think he wants your thoughts around that idea.
Well, Mark, I'm not sure about chaos testing. I have actually never seen chaos testing in live, in real, say, in real execution. But you're certainly right to say, yes, functional explanation can be found in chaos testing, but not sure whether this chaos testing actually is then really doing testing in the right direction. That is, whether it can create the confidence level that we actually need for the cyber-physical products.
I think that's fair. I have a quick question for you, because you did talk a bit about kind of combinatorial practices. Do you prefer, when you think about kind of applying those combinatorial techniques to testing, do you prefer to like do this by hand and use like an orthogonal array, or are you like me and you go more tool driven to help you do some of that analysis and help you kind of create those test cases?
Well, not sure whether I've understand it right. If you create these test cases, the point is this is something where humans are in charge and they have to do the work, but they can be helped by, well, algorithmic, by machines, by mathematics. I mean, basically, finding the right test stories to match them with the user stories is a very, very difficult and creative task. Not something that can be automated, not at all. The only thing that can be automated, and this is probably typical also, when you actually do this test coverage matrix, you can evaluate whether you have a chance that your test stories actually will ever be able to test the user stories, thanks to the evaluation of user stories from the user values. So you can check, but it does not do that automatically.
Oh, no, I absolutely agree. When we're thinking about coverage mapping and traceability, that's by hand. There are tools that will help you identify if you have a gap, but you're still going to have to put in the work on that. I 100% agree. I was more thinking about within those test cases that we are aligning to our user stories. Within our traceability, I come from a background of insurance. So it wasn't uncommon for me to have massive sets of data that needed to be considered, multiple parameters that had to be aligned. So I would use combinatorial tools to help me kind of create the orthogonal array of all of those data sets, as opposed to doing it by hand. Yeah. Because I'm going to be honest, I hate doing it by hand. I know how to do it, but like if I can use a tool, I always will. And I was curious what your thoughts were on that. Is it actually better to put in the work and do it by hand, or do you agree that like a tool just makes your life simpler?
Well, I'm, as I said already, I'm a mathematician, and mathematicians are very, very lazy people. It is, we prefer it so much to have machines doing the work for us. And then just understanding what the machine does. Probably this makes the difference. But you're absolutely right. I mean, with 37 data movements, you can't actually run autonomous vehicle. You have, and with 6 user stories, you never do a project. So those that I actually work with, they have 5,000 user stories, 1,000 user stories at least. But if you're looking after things like an autonomous car or something, you get even with the number of user stories, you easily can get 5,000 to 10,000. And if you do that all by hand, you won't be able to do it. You must be able to categorize it. So you probably need already the artificial intelligence just in order to find out what you're actually going to do. Or at least you need these algorithms, big data algorithms, to find out what is important and what is less important. And no, you want actually, I mean, you need your brain and the spirit and the creativity to really find out what could be the best solution. But let the computers do the work. the hard work.
I completely agree. I tell people all the time, we as humans can think and feel and rationalize and decision. Even AI can't do that. Let the machine do the repetitive stuff. Let our brains do all of the important stuff. Well, we are out of time, and I'm so, so grateful for your talk. This was fantastic. Philip, by the way, said he agrees with you. He's a math person, and he also uses tools. So I'm so, so grateful. That was fantastic. I can't wait to rewatch it because there's a lot in there, and I want to kind of like get a chance to pause and think through things and watch again. But thank you so much. That was fantastic.
Thank you very much.